So in this video we are going to see about the introduction about the linked list. So it is a linear data structure in which elements are not stored at a contiguous memory location. Okay, so if we take the array, so in the array what will happen if we take the array A of 5, okay, so the size of the array is 5. Okay, so what will happen, the memory space will be allocated for this array. Okay, so 1 2 3 4, so 5 memory space, and the address space will be for integer I'm taken as a int of A of 5. So 100, so array size is 2, sorry, integer size is 2, so 100 102 104 106 and 108. What will happen, the continuously the memory space is allocated to the array in a memory. But in a linear linked list, here the elements are not stored in a contiguous memory, it will be randomly allocated. And element in a linked list are linked using the pointer. Okay, linked using the pointer. So linked list is a linear collection of a data structure, and here the data elements are called as the node. So here we are using the node. So the node is divided into two parts. So the first part contains the data, and second part contains the pointer to the next node. So that is, it contains the address of the next node. And this linked list is a data structure, and it can be used to implement the other data structure like a stack queue. You can implement the stack queue, etc. And same time we can implement the stack queue by using the array also. And it acts as a building block to implement the data structure such as stack queue and other variations. So it can be preserved as a train or a sequence of nodes in which each node contains one or more data fields and pointer to the next node. So why it is given one or more the data field means, for example, if you are taking the priority queue, so the priority queue can be implemented by using the linked list concept. So in the priority queue, it contains the data priority. So what we will do, we divide the node into three parts. So the first part contains the data, then second part contains the priority, and here the pointer to the next node. So that is only given, it contains one or more data field and the pointer to the next node. So this is the representation of the linked list. So the first node is a start node or it is a head node. Okay, and here it contains, the first part contains data, and it contains the second part contains the address of or pointer to the next node. And in the last node, the address point, we have to denote the null. Okay, so the meaning is, after this particular node, it doesn't contains any node. And this linked list is classified into many types, that is singly linked list, doubly linked list, circular linked list, doubly circular linked list. So these are the different variation of the linked list. And in a memory representation, this is the memory representation of the linked list. Okay, so here this is the start node, and in a start node it contains the data as a h. Okay, so here data as a h, and in a memory space it contains the address. In the next part, in the next column, it contains the address of the next node. So what is the address 4? So where is 4? Is 4. So it contains the data e. Then what is the address for the next one? It is a 7. So in a 7. So here it contains the data as the L, and what is the pointer to the next node? It is a 8. So it is 8. Then here the data is the L, and what is the pointer to the next node? It is a 10. Then here it is the O, and what is the pointer to the next node? It is -1. So what is the meaning of the minus node? It is a null. After this particular node, there is no any other node. So that is, it is the last node. And when you are implementing so when you are doing the implementation, we have to use the following code. So here for the implementation, we will use the structure concept. So the struct node and in data. So we are using two members in this structure. One is in data and another one is a struct node star next. So this is a self referential structure. Okay, it is a self-referential structure So what is self-referential structure? So it is also one type of structure that has a one or more pointer which points to the same type of structure as their member. Okay, it also having one or more pointer which points to the same type of structure as their member. So otherwise, in other words, we can define structure pointing to the same type of structures or self-referential in nature. Okay, structure pointing to the same type of structures are called as the self-referential structure.